These examples involve making amines by various reactions in chapter 22. And before we start, I wanted to just review the reactions. This is what's actually at the top of the handout with the problems, but I shoved it on the bottom here because I originally got rid of it. And so just to summarize, you can make primary amines via the Gabriel synthesis, reduction of an azide after first making the azide, or reduction of a nitro group or a nitrile. Remember that when you add a nitro or an azide group, that adds just the nitrogen. It doesn't also add a carbon, whereas when you make a nitrile, say from an alkyl halide, that adds a carbon and a nitrogen. And the Gabriel also just adds the nitrogen. And the reason we use the Gabriel synthesis is because you can't, with any great success, directly alkylate an amine because it just keeps alkylating. And she talks about that in the UCI video lecture. So you can, by reducing a primary or secondary or tertiary amide, you can get the corresponding primary, secondary, or tertiary amine. And the one kind of tricky thing to remember here is that when you do that, students sometimes forget about this carbonyl carbon. So remember that the carbonyl carbon becomes a CH2 when you do that. And then you can also make primary, secondary, and tertiary amines by reductive amination. And here, for a primary amine, you're going to use ammonia as the nitrogen source. For a secondary amine, you're going to use primary amine. And for a secondary amine, for a tertiary amine, you're going to use the secondary amine. And here, the alkylating agent is an aldehyde or a ketone. So that's your alkylation source. So that makes sense. If you have a primary amine and you add one alkyl group, then you're going to get a secondary amine. And these reactions occur depending on the type of nitrogen nucleophile that you have. These either occur via imines for using ammonia and primary amines, and then via enamines if you're trying to make a tertiary amine from a secondary amine. So now we can go back up and look at, I think I have 5 examples. All right, and I don't know why I put them in the order that I did. Made more sense to do a different order. So here we have an alkyl bromide with 1 carbon external to the ring. And so clearly we're going to have to make a carbon-carbon bond here. And notice that we're adding a carbon. And so that means that just, using, say, a Gabriel synthesis here is not going to add that extra carbon. So we need some way of adding an extra carbon, and this is the way I've chosen to do it. It may or may not be the best or the only, well, I know it's not the only way. So I made a note here, Gabriel won't work, nitrile would work, and amide would work. I happen to choose the amide via the carboxylic acid. So we're going to take our alkyl bromide, make a Grignard, carbonate the Grignard, make a carboxylic acid. There's our carbon. Now all we have to do is make this amide, but you can't make an amide directly from a carboxylic acid. You have to first convert it to the acid halide, then add an excess of the amine. Remember that one equivalent of the amine reacts to make the amide, and the other equivalent neutralizes the acid that's formed in the reaction. And that's an appropriate thing to do here because ethylamine is pretty cheap. And then finally we can reduce this with an excess of lithium aluminum hydride and add water to get the final product, which, even though I kept reducing the size of this thing, I could not fit here. And again, you also could have done it by making, say, this nitrile, and then reducing that nitrile to a primary amine, and then you could probably do a reductive amination to add that ethyl group. So either one of those would work, and those probably aren't the only two ways to do that. So one of the things I tried to do with this series is kind of do a comparison where we end up with, here we have the nitrogen is directly on the ring. Here we have the nitrogen, one carbon away from the ring. Here it's 2 carbons away, although we're kind of setting ourselves up for that. Here we have a ring, so it's kind of like we add a carbon and a nitrogen. So I was trying to get you to look at these different cases of what you add to get the nitrogen in a given place. At any rate, so here we have benzene, and we're supposed to make this amine. So the only way we can really get a nitrogen directly on the ring is via a nitro group, which we can reduce a variety of ways. I like the H2 over PT because it's less to write. That gives us the aniline, and then we do a reductive amination with this aldehyde, which adds 1, 2, 3, 4, 1, 2, 3, 4 carbons. And when you do the reductive amination, you just throw everything together in the same pot. It's what all of you guys have been trying to do for 2 semesters. So you take the carbonyl compound, the amine. You need to get to a somewhat acidic pH so that you can make in this case, it would be an imine. And then this is the specialized reducing agent that's used for these. In order to do this particular reaction, you could have also acylated this with this species and then reduced it. But one of the things I was trying to do with this sequence of problems is show you different ways of doing them. In theory, yes, you could do this by doing a benzyne reaction, but benzyne reactions in real life are not all that practical. But if you did it on a test at your pay grade, I would accept it. So with this next one, which is the one I probably should have done first because it's the easiest one, all we're trying to do is replace this bromine with an NH2 group. You can't do this by directly alkylating ammonia because it'll just keep alkylating away. So in order to go from a primary amine with the same number of carbons, we can either use the Gabriel synthesis, or you could make the azide and reduce that. So to do the Gabriel synthesis, you add this anion of phthalimide, and then you hydrolyze the resulting compound. So the intermediate that you get here, actually that's a pretty small piece. There we go. So the first thing that happens is that this does an SN2. And the whole idea of the Gabriel synthesis is that you've blocked all the other positions on the nitrogen so that only the nitrogen can only add once. So that gives you this species. And if you look at this compound, it's kind of like the amide version of an anhydride. And classically, we hydrolyze these things with H3O+. Apparently, more modern way to do this is to add this compound and the hydrazine, and that will also work. So I'm fine with either one. If you use the H3O+, you would need to follow this up with a base step to deprotonate the amine from NH3+ to NH2, but you would not need to do that if you did this step. So this next one, we have a 1, 2, 3 carbon chain, 1, 2, 3 carbon chain. So what we need to do is replace this group with this group. And so we have kind of two choices here. We can think about, I guess either way it's going to be that way. So essentially we need to turn this into an electrophile so that we can add an amine to it. I was thinking for a minute that there wasn't a way to switch the electrophile and the nucleophile, but there isn't. So we need to turn this into the electrophile. And so what we can do here is this reductive amination. Here's the new bond that we have to make. And so this is a secondary amine from methylamine. So we'll need methylamine in our reductive amination. But in order to do the reductive amination, we don't need an OH here, we need a carbonyl. So we're going to start here by oxidizing this to the ketone, and then we do our reductive amination, and we add this piece, and this, yes, this is methamphetamine, and this is one of the ways that methamphetamine is apparently produced illicitly is by a reductive amination. There are several other ways, and I'll just refer you to Breaking Bad or the internet for that. So finally, we have a case where we're going from benzene to a molecule where instead of the nitrogen being directly attached to the ring, it's on the benzylic carbon. And what we have here is a tertiary amine. Really the only way we have of making tertiary amines is either by amides or by reductive amination. If we do this via reductive amination of this ketone, so ketone here, that will work fine. How do we get this ketone? We just acylate the ring. So we take the benzene ring, we do a Friedel-Crafts acylation, 1, 2, 3, 4, 1, 2, 3, 4 carbons. That makes this phenyl ketone, and then again, we use a secondary amine, the dimethylamine, to use in the reductive amination. And if you look at the book problems for the synthesis of amines, they have some where they say, you have to start from ammonia, and they don't really give you any other guidance. If I give you synthesis questions, I'll give you something where I give you a specified starting material and then obviously a specified target compound. Before the next test, I'm going to write out some somewhat more advanced synthesis problems, or at least synthesis problems that combine material from all of the chapters that are on the test.